So it's nice to sort of be back into sort of kind of familiar territory. And what I want to speak to you tonight is about our rivers, globally, but also nationally. And what I really want to get across to you, and I hope that we can engage in a bit of a discussion, is why we should care about our rivers. And there are all the obvious sort of reasons why we should care about our rivers. Most of you probably enjoy walks on rivers. You probably, maybe some of you fish, maybe some of you have boats, all that kind of stuff. Maybe some of you even go swimming or wild swimming. But there are other reasons why we need to really care about our rivers. And I want to just explore some of those, because for me, these are stories about rivers that are not told. And I think we need to understand these stories if we're going to appreciate them. And then I think what I'll try and do is zooming a little bit and maybe chat about rivers in the United Kingdom and maybe a bit of an insight into where we are. And then touch very briefly, not too much, in an area of research that we're doing. And I must recognise with some of the stuff that I'm going to be presenting, a colleague of mine, who's Eva Perrin, who's conducting or doing, just finishing actually, her PhD research in river health and river water quality. Happy to take questions whenever. So if there's something that I say completely wrong and you don't get, then just interrupt. So I'm quite okay with sort of that interaction, if that's okay with you, but I'll leave that for you guys to decide. And I hope everybody online, hello online. So we do lots of lectures at university where we're streaming and online, and we're always very aware about the online experience. So just to say hello to you guys that are somewhere else watching. And again, if there's any problems, feel free to message in the chat and we can try and sort things out. But welcome to all of you too. Okay. Right. Okay. Relief. Many of you may recognise this picture. It's the reason why I got into science. It's Earthrise. It's a picture taken from one of the Apollo missions, and it shows the fragility and the beauty of planet Earth from the moon. And it is an amazing thing. Now, I don't know about your persuasion in the audience. I'm a scientist, so I, often teach a lot of our students about the creation of the universe, about it's the creation of the universe in 1 hour, that kind of thing, right? So, but I think I always tell my students, we have to really be aware that we are living in a very unique and special place. And that's really important to understand. As far as we know, we are the only planet in our observable universe with life. Now, you get scientists like me saying, of course there's life, because the universe is infinite and all that kind of stuff. And we're looking for planets with water. And of course, all that's fantastic and it's great. Yeah, and I love all that. And it got me into science. But the brutal reality is, with all probability, we will never hear the voices, we will never receive the messages of any life that is out in that infinite, vast, expansive universe. So we are it. Yeah, this planet is it from our perspective. And one of the reasons why we have life on this planet is because we have water on this planet. And water is an amazing molecule. It's an amazing thing to even exist. And we really tried to work out where water came from. And there's a lot of hypothesizing about the origin of water on Earth. Yeah. And the front runner for a while was an asteroid of some kind, or a meteor, yeah, that contained water and dispersed that, because we have a lot of features on Earth that are very commensurate with meteor impacts. But we're not in that position now. We actually think water has been around for as long as the Earth has been around. So actually it was formed 4.5 billion years ago. And a certain way in which it was formed through that accretion process meant that we didn't lose a lot of the volatile stuff that was formed in that initial process. So we think the water that we have on Earth is as old as the Earth, which is 4.5 billion years. And the thing about that planet you can see up there is we're not getting any. I'm getting directions to Earth. No, we're not getting any deliveries. We're not getting any deliveries. Amazon is not visiting us from another planet. It's not giving us more nutrients. It's not giving us more iron. It's not giving us more carbon. What we have to sustain the planetary system is on that blue ball, hurtling around a middle-aged star, and has been for the last 4.5 billion years. But the way we interact with that planet does not square up with those facts. We consume, we generate a lot of problems in relation to waste, and we really have a view that it's a limitless plane. Yeah, that we can go on to the next bit, and that we can discover, and we can use and exploit the next bit. And we can't be like that. We have to understand that we are living within boundaries, and that we have limits, and that we have, in the pantry is what's in the pantry. And of course, over millions of years, what has developed to help us out with these things is this architecture of life, the architecture of the world around us, the ecosystems, the forests, the seas, the atmosphere, the bugs, the bacteria, the viruses that are constantly fighting it out with each other, mediating this very prescribed amount of carbon, phosphorus, nitrogen, and all the rest. And they are the real workers. They're the ones that are doing all the work, moving and making this stuff available in a way that can sustain and build these magnificent architectures that we see around us in relation to life. So we have to be mindful of that. And that evolutionary process that's happened means that the planet is very good at using the resources it has in a very sustainable way. Yeah, because it makes the system work, and it sustains that system. And the only thing coming in from outside is sunlight. So the whole thing pretty much is solar powered, and that's it. We come along, and we have had a profound impact on Earth and how it functions and the systems within that planet. And we need to be better at understanding that. And we need to be better at understanding those systems. Because I do think, the existence of people, and certainly the existence of much of life, depends on it. And I'll articulate a little bit about that as we go along, with a specific reference to rivers. And we're a blue planet, we're an ocean planet, okay? And that's what makes us so special and so unique. But of course, underneath that water, we're really just a big ball of rock, with a little bit of molten stuff and a little bit of a solid iron core in the middle, and lots of interesting things happening. But if I was to suck up and hoover up all of that water, I could represent the volumes, the respective volumes of water as seen by those blue bubbles. So that big bubble, that you can see, although it doesn't look too big, is all of Earth's water, sucked out of that ball, that 4.5 billion year old rock, and displayed as a bubble. And it turns out it's about 860 miles in diameter. So in theory, you could drive through the whole bubble of water on Earth if you start off at Penzance and then finished more or less at John O'Groats. The medium bubble, is all the liquid fresh water we have on Earth. Because a lot of the water we have is locked in living things or rocks. It's also present in the atmosphere. But the liquid water we have, salt and fresh, surface and ground, would look like that middle bubble. And that middle bubble is only 170 miles in diameter. So what's that? That's probably, well, it's not very far. Yeah. And that very tiny bubble you can see there is all the water available to us from our fresh water systems, our rivers and lakes. And that is about 35 miles. So that's, you know, Bristol, or well, Bath to Cirencester. You can travel through the entire volume of all fresh water available to us from rivers and lakes on planet Earth. Now that's how much water we have to rely on in the main. All right. There's also quite a reasonable amount from groundwater, but even if I chuck that in, yeah, that's that tiny speck. And water is so important to us. It's so important from a human perspective, so important from a planetary perspective, and it's so important for life. So we think we're awash with water. The reality is we are not. And then we'll see. And I just want you to watch this, and then we'll move on. Right, I could do some volume. What's going on here?
Yes, I'm not hearing it on there
Maybe the main system isn't. Is there a volume button on this side, but out of the screen?
I think everything's there, or it should be on this one as well.
Yeah. Well, it's only music.
Well,
yeah. What's music done for us? Okay, that's all right. So I'll do the voiceover. So we'll watch that again. And this is really articulating. So there's no talking actually. It's all it is articulating a little bit about the life that exhibits our freshwater species. And they're incredibly diverse, but they're also extremely vulnerable, and they're also under extreme pressure. And I'll talk a little bit about some of those things. Oh, it's going well. Sorry. No, it's not letting me move on either. Gotcha. So what that video is trying to illustrate is the diversity that we have in our freshwater systems. So 40% of all fish reside in our freshwater systems. And our freshwater systems cover a really small amount of the Earth's surface. So oceans are pretty diverse and pretty varied, but our freshwater systems occupy around 1%, maybe 2% of the Earth's surface. And they're split up into about 200 million different types of surface water bodies. And some of them obviously are very iconic. So the Ganges, yeah, the Thames, all those things, the Great Lakes. But more often than not, a lot of them are small in nature. Yeah, they're small bogs, or they're small streams, or they're much smaller rivers. But these incredibly numerous and incredibly diverse spaces are homes for quite a lot of our life that lives on planet Earth. And I think when you look at the statistics and when you look at the evidence, so this is, on one side there's the passion, but on the other side there's just the evidence and the facts. It's not too great, I'm afraid. So species that live in our freshwater systems are declining at probably the biggest rate out of all of the other biomes. So if you looked at the oceans, if you looked at the forests, on all the different kinds of biomes, freshwater systems are suffering the most. And I kind of think that's probably kind of a rational thing, because we rely on water so much. We use water so much. And which civilization that we all heard or learned about at school did not start somewhere near a great river, whether it's the Tigris or the Euphrates, whether it's you know, the Nile, or whether it's the Thames. You know, so it's not surprising, I guess, that in some instances they are the most at threat. Now that curve there, the white line is the measurement and the blue line is the uncertainty. And we always have a lot of uncertainty in our measurements. And this is looking at a total of about 3,300 or so different populations. So this is looking at the populations of a certain species somewhere around the Earth. Okay, and we're doing that 3,300 times. And we're monitoring those over every 5-year periods. Okay, and that is all part of the Living Planet. We call it the Living Planet Index, and it ascertains the current change and state of some of these biomes. It does it for forests, it does it for freshwaters, so on and so forth. And since 1970, the evidence is telling us that our freshwater systems have been subjected or have suffered a decline of around 84%. And it doesn't matter how much we can go around this numbers and science and certainty, but all the best science that we have, and I know because I work in the field and I do these things and I've seen it with my own eyes, is telling us that we're getting very, very steep declines. And the decline in our freshwater systems is much greater than the declines observed in other biomes. And our water really is driven by various functions. The quality of it, the chemical quality, maybe even the biological quality of it, the amount, and boy, don't we know, over the last 10, 20 years, we don't either have enough or we have way too much. So the whole system, that help to drive these freshwater environments is also changing. So everything is connected. Rivers, they deserve to flow, and they're not flowing. There's lots of disruptions to our rivers for a whole number of reasons. And I'll talk a little bit about that. The habitat of our river systems is changing because how we're using land, what we're putting into our rivers is changing. And we need to appreciate that. So habitat loss is probably the biggest driver. And I hear this more than anything else, whether it's forests, whether it's the art, it's habitat loss. The place where you live has fundamentally changed so that you're not able, or you don't have enough adaptation to live there. And of course, ultimately, that's impacting on the diversity. And the diversity of living things in rivers is really important. So for instance, under every surface of every river is a whole invisible community of millions and millions of bacteria, viruses, algae, autotrophs, phototrophs, and they're all doing that work. They're all munching up that material and driving it through that earth system. And we have a conceptual model. We like models in academia, and this conceptual model is about how can we describe catchments, how can we describe rivers. And the general sort of model is you have your landscape, your catchments, and then you get the production of all these important things through the good work of soils and the natural things that happen in soils. You then have the hydrological export, or the hydrological influences in moving that material. So you move material off the land and that will get transported through these river systems. And they'll go down estuaries. The reason why you see birds at estuaries is because they're very rich in nutrients, okay? And then estuaries are then subsequently feeding that material out to the world's oceans. We know that, you know, rivers are very much influenced and flavored by the landscapes they cut through. Yeah, so they've engineered and sculptured the landscape. So in turn, the landscape itself really drives the hydrological and the physical and chemical characteristics of the river. So I know rivers down in Dartmoor are fundamentally different to rivers up in Bristol or rivers in the Cotswolds, right? Because the geology and the land, yeah, and how we use it differs. And that's also an important consideration. And of course, when you feed all these things to our conceptual model, you then understand the response of that system in relation to life, yeah, in relation to the living things in there. And of course, for that sort of purpose, we do exactly what I showed you in the previous slide, which is go out and count populations of big things, fish, creatures, things, wiggly things, you know, frogs, amphibians. You count them and you study them and you try to understand that. But they are a product of a whole range of other processes, right? So they are the kind of the manifestation of all of that system. Yeah, they are not the end point and they're not the start point. And of course, the job for us as scientists is to understand and predict all of that through time and through space. And that's really, really difficult. It's really difficult. Okay, and I'll maybe touch upon that a little bit. So if we just touch through soils, okay, and this kind of production of all these important nutrients we need for so many things, certainly as humans, we need them for food and we need them for all that sort of stuff. One of the biggest drivers of soil degradation is deforestation. And one of the biggest reasons why we cut trees down mostly is agriculture. All right, some of it is also timber production, things like that, but it's mostly agriculture. This is Rondônia in Western Brazil. So it's just, for those of you that know Brazil, there's a state which is just south of Amazonia state. And this over, a 30, 40-year period shows the change in deforestation of a certain particular area. So in 1975, there were about 208,000 square kilometers of forest. And you can see that through that timeline there, and that little dash represents a negative. So it's, in 1978, we lost, or 4,200 square kilometers of trees and forests were lost. In 1988, that was 30,000. Just over 53,000 in 1998, and we latest estimate, I haven't caught up with the next one, but with the current regime in Brazil, and certainly the desperate need for economic activity that we're all facing with at the moment, it will be much higher than that 67 or 8,000 square kilometers of forest chopped down. Now that directly drives soil degradation. And in fact, soils, in my view, are one of the most understudied and talked about assets on planet Earth. We need to do something about them desperately, all right? And we need to understand what we can do and when not. But that's a driver, and that's degrading soils. So that's one of those sort of impacts. If we look at the effects of hydrology, and remember that the current model is hydrology transports this material. Okay, so it's transporting all this stuff from soils, so from a headwater, and it will transport it through the environment. And it gets used in certain ways and by certain species as it moves through that through that environment. But in relation to material transport, we know that a lot of our waters on planet Earth, the flows are changing. Yeah, the quantity of water, yeah, is either too much or too little. So this is a study done by the National Centre for Atmospheric Research, and they did a study calculating the changes in water flows across Earth as best as they could. So in the Pacific, we estimate, this is fresh water, right? In rivers and reservoirs, all that kind of stuff. We estimate in the Pacific, there's a drop of 6% in total of the amount of water that's entering the Pacific. To put that to some magnitude, that's about the volume of river of water that flows through the Mississippi every year, 6%. We also know in the Indian Ocean, yeah, we're getting changes of flows within about 3%. So this is not insignificant. And of course, in the Arctic, we're getting, the Arctic Ocean, we're getting an increase. Does anybody know why that might be? Yeah, because of course, a lot of the ice and a lot of the glaciers are melting. So it's a very complicated picture. And I'm not doing it justice. I'm just trying to give you some information to sort of deal with. And this area I want to talk about a little bit. So this area here, does anybody know what that area is? I haven't got any prizes at all, if anybody knows the answer. But the one with the yellow bit where the arrow is. If you could point with yeah, so I slipped that in there when you weren't looking. It's my little lose a sleep test, that was. But that there, does anybody have a? It's the Himalayas and it's the Tibetan Plateau. And of course, the interesting bit, very good, excellent, that's good. So, yeah, so that kind of blows out my next 4 lines because I'm going to tell you all about it if you already know. But that's the Tibetan Plateau. And the interesting thing about that is it's transboundary. And that's another great feature about rivers. They don't care. You know, they don't care about these artificial human constructs called boundaries or borders. You know, they go wherever they go. And that sort of Tibetan Plateau is where, you know, the glaciers on that feed 10 of the world's great rivers. So it feeds the Ganges, it feeds the Yangtze River, so on and so forth. And actually, what we think is that area is at the moment relatively stable. Right? We think it's relatively stable. There are some signs of its inevitable demise, but it's relatively stable. And what I want to sort of just spend a couple of slides talking about is why the flow of water is really important. So the circle on your left is the number of dams that are currently, that we know about in China. And there are an estimated 50,000 dams in the world. And 20,000 of those, yeah, exist in China. And there's a square, there's a square here, isn't there? Because on one hand, there is a cry from the West about net zero. Yeah, so hydroelectric power. But on the other hand, we're disrupting these flows. And I'm going to hopefully have a discussion with you later about why flowing water is so important. So 20,000 of these dams have been built, I think, over the last 50 years in there. And in the Tibetan Plateau, there is a specific river, right, which is Yarlung Sangpo River, which cuts across and meanders into India a little bit, skirts along Nepal, comes down and feeds and enters into Bangladesh. So some very hot, political, sensitive areas. And those red dots you can see there are current dams. Now, hydroelectric power from rivers in the Himalayas is such an enticing prospect. So the Yarlung Sangpo River is the highest altitude river on Earth. The highest point is 4,000 meters. All right. And there's a lot of interest in that from the Chinese government as a means of building probably the most ambitious engineering project ever seen on planet Earth, which is a huge hydroelectric dam somewhere in the Himalayas. The accessibility, the fragility, it's also a geological hotspot. Yeah, you get lots of tremors, quakes, landslides, so on and so forth. And this little kink here is referred to as the Great Bend. Yeah, it's almost as a U-turn, the river, right? It's magnificent, the 10th biggest river on Earth. And it kind of does a massive U-turn and heads back sort of west, I guess. And they're really interested in this specific bend. And that's what it looks like, yeah? Or one of the bends. So amazing feature, very inaccessible, very remote, lots of flows. and all that sort of stuff. But the great thing about this particular bend is from one side to the other, there's approximately a 3,000 meter drop. So you think about that volume of water dropping the best part of 3 kilometers. Okay, you're talking a massive source of energy. But of course, people downstream to that are not so keen on the idea. Yeah. And the transport, I mean, you look how brown that river is. Yeah, there's lots of, I call gelb stuff, organic material, lots of particulate matter. The transport of that material, if it's done through natural processes, is really important, right? Because it's all part and parcel of the carbon cycle. And we estimate that, you know, this damming of rivers and this obstruction of rivers and the interruption of the flow of rivers is retaining about 20%. Maybe 25% of all the material that is usually transported. And that is problematic in itself. So if you talk to people that supply water through reservoirs, they know this problem and they keep it quiet. There's a big sediment of solid material sitting at the bottom of reservoirs, yeah, which are contaminated probably. But the biology at the bottom is different. If you know, when you go into a stagnant pool and you poke the sludge at the bottom, what do you get a whiff of? You get a whiff of methane, you get a whiff of sulfide. It's anaerobic, yeah? So the biology is fundamentally different. So these places are also kind of a little bit worrying for the release of other greenhouse gases, which are potentially more adverse than carbon dioxide. Certainly methane probably has a greenhouse gas potential, maybe in the order of 10 times more than carbon dioxide, maybe more. So this great elevation, sorry, 2,000, not 3,000, this great elevation that we have is of particular interest to these engineers. And of course, this is very worrying for people that are down below. And we know changes in hydrology fundamentally change the quality of our rivers. So this is a study we did on the Ganges. So we did about 100 sites. We sent 3 or 4 teams over a 3-4 week period to study and take samples. And we did, you know, basic stuff, biology stuff, nutrients, all that kind of stuff, and collected all of that information. The first time that's been done on this scale over this 3 to 4 week period. Lots of flaws. Yeah, because actually collecting samples from the Ganges is not straightforward. Doing it over a stretch which is 2,500 kilometers is not straightforward. So you can't all stand there with your phones and go, right, 3, 2, 1, collect sample. Yeah. So there's time series difference, but it's one of the best studies that we have. And doing work in India is really, really difficult. And it's really, really difficult because water is very politicized for those very reasons that I was discussing in the previous slides. So you're not allowed to sample from bridges. It's illegal. You'll get arrested. You have to ask special permission. And we think we do paperwork. My colleagues in India are exceptional at paperwork and generating it anyway. So it's a very lengthy process. So we undertook this study. I'm working with University of Manchester, Birmingham, the British Geological Survey, Central Government. We led the sort of scientific endeavour, as it were, coordinate all the sampling. And we're doing lots of things at the moment. And what we know from our work in that is that these hydrogeochemical dynamics are massively impacted by how we use that river. So if we change the flows, that changes the quality and the dynamics of what that river does. If it runs through very heavily populated areas, then again, the hydrogeochemical dynamics fundamentally change. The big question is, so what? Well, the so what about that is the impact that has on moving and accumulating pollutants. So we found a really huge amounts of plastic, yeah, microplastics. We found traces of antimicrobial resistance. We found heavy metals. We've obviously found lots of bacterial contamination. We found changes in diversity of microbial communities, and all of those things are driven in part through that concept, that framework that I showed you. Yeah, changes in flow, changes in how the land is used, changes in discharges. And these are having profound implications for how we interact with that river and what that river is able to provide us. And there are 650 million Indians, yeah, that rely in some way or another on that river. So it's a big, big, important thing. The next driver is land use. And agriculture is really important. We need to grow food, right? I mean, that's just, we can't stop doing agriculture. It's not possible. But about 70% of all water abstracts are used for agriculture. That's 70%. So it is a massive water user. And we need to do better and be better in about the efficiency and integrating technology into that certain thing, yeah, into this sector. Chopping down trees is important in agriculture. Clearing forests is important. And we estimate that about 40% of our forests have been lost as a result of agricultural practices. We estimate that 40% of the wheat or grain that we grow on agricultural land is used to feed cattle. So there are very complicated problems. So this is not about not wanting farming. I want farming. I want food growing. But it's also about understanding the reality and seeing if we can do things differently. Yeah? And maybe integrate different practices. So agriculture is a really, really, really big influencer. And outside of agriculture, there's also the constant depositing of untreated sewage in our rivers, or in many of the world's rivers, certainly in places like India, where you have an open sewer system, actually. And that is also profoundly changing the quality of the water, which in turn is driving its availability and use for things like agriculture and growing food. And we managed, again, in India, we did a bit of research which showed very clearly that the bacterial contamination varies in different types of water bodies. And they have a huge wetland in Kolkata, actually, and they use it for treating a lot of their sewage. And you would expect, and they actually do a lot of fish farming, agriculture in there as well. And there are a lot of urban canals, and there are a lot of rivers, and all of them exhibit signs of stress in one way or another. And all this matters because our rivers are actually alive. Our rivers are a kind of a part of a very large global digestive system. And what's happening or should be happening in those rivers to varying degrees, maybe less if they're fed from glaciers, but certainly very high if they're present in the tropics, is they should be processing all of that stuff that we need. The stuff, the fixed amount of stuff, the carbon, the nitrogen, the phosphorus. And they should be playing a key role in that. And they do play a key role in that. And the largest absorber of carbon are land-based ecosystems, and that's about 120 billion metric tons. But they release back into the environment about 115. So there's a little difference that we can't account for. And we think that 5 billion metric tons is in some way or another dealt with by these 200 million freshwater systems. Now that 5 billion is actually quite a lot. This is net primary productivity or production. And that carbon just doesn't sit there, it moves. And one of the vehicles and places and routes where it moves is through rivers. And rivers are playing an important role in that. The thing is, because it's so difficult to study rivers, we don't really have any idea as to how much is being processed and what we're doing to our rivers, how that's affecting that processing. So we're a little bit blind, and it doesn't appear on climate models. Oceanography is really sexy. You get to go out on a boat and do lots of interesting work. Trampling around in forests is really good as well. Nobody really wants to be, walking up and down the River Rother, and doing those kind of things. So we're a little bit naive and a little bit ignorant as the importance of rivers in that regard, but they are a massively important component of the carbon cycle. And in total, the amount of carbon that these systems emit is comparable to the net amount of carbon absorbed by all living organisms on Earth. Yeah, on the surface and in its oceans. And I describe them as the broadband of carbon. So a lot of these other systems are a lot slower. Rivers are very, very quick. Yeah, they're very, very speedy. And these systems bury more carbon in sediments each year than the vast ocean floors. So they're crucial. And our knowledge or lack of knowledge in this is a threat. And we have large unknowns and we have much uncertainty in regard to this. And we lack adequate data. And we lack adequate data because we don't really measure the right things. We've been stuck in this leap of what do we measure? But we don't have the right sort of data to plug into the models. And one of the big areas of uncertainty is in this question: what is happening in the rivers? You know, what is those microbial communities doing to this carbon that is entering these systems? Maybe from the head, yeah, which has been transported in, but maybe also in situ, because some of these rivers are thousands of miles long. So this processing occurs along a continuum. And the other big unknown, because we don't study it enough, ironically, is how are our activities impacting on this processing? And we need to understand that, because if we're going to have a cleaner world, if we're going to drive to lower carbon emissions, this is really important, because if we lose control of our rivers, we're losing control of a biological living network. And that's going to be very, very difficult to manage, right? And this perspective is very new. You know, it was only recently integrated in the IPCC's reports on climate change. And I'm always very critical. I mean, it's a very difficult job, but I'm always very critical, and have been, that these reports have not contained more specific information relating to rivers. They made a brief appearance in 2013, but that description was, you know, paragraph, maybe, at best. So we don't really fully understand what human activities are doing and how they're impacting on the function, the ecosystem or ecological function of our rivers. And this comes down and round to how we measure them. And how we have been measuring them is we have a classification system: high, good, moderate, bad, or poor. In order to sort of pass the test, you have to have a result of high or good. And we really measure two basic areas. It's a bit more complicated now, but we focus on chemicals, so the chemical quality, and there's a suite of 200 chemicals that they look at, you know, emerging contaminants like phthalates or plasticizers, endocrine disruptors, all these kind of names that nobody really understands, but also nutrients, phosphorus, nitrogen, all those things. And they also look at the ecological health. Now, from the physical and chemical, it's relatively straightforward. You know, you can get a probe, you can stick it in the river, and you can get some data. Some of those parameters are a bit more difficult to measure, but it's very lab stuff. And from the macrobiological or the ecological, this is really about doing fish surveys and invertebrates. Very labor intensive. You know, you're not really going to get very resolved information. And there's a technique to doing a kick sample. So there's lots and lots of interesting difficulties in assessing the ecological health. And we've been going through this for many, many decades, right? We were doing this a little bit before we joined the EU. We certainly adopted the Water Framework Directive as part of the EU. We've left the EU. Brexit has nothing to do with this, right? That's the first thing. This is about how we go about monitoring the world around us and making sure that we inform our decisions based upon the best available information that we have. And in England, for example, not one river, not one, yeah, river is classified as acceptable. All rivers in England are not acceptable when you take into consideration the chemical quality and the ecological quality. And most rivers actually, well, all rivers have failed on the chemical quality for various reasons. A lot of that could be nutrients or something like that. But that is the current state of English rivers. And it took me at least, I would say, 7 hours to find this information out. You know, it's not information they really want you to get hold of. So crawling through the Scottish Environmental Protection Agency website was pretty turgid. Yeah, and it was hidden, buried nice and deep. But even Scotland, you know, where you would think, you know, it wouldn't be unreasonable to be in the 90s. 66% of rivers are in good health, whatever that means. Couldn't quite get any more from that. But we do know that there are increasing concerns about sewage discharges. In Wales, only 46% of rivers in Wales are in good health. In Northern Ireland, it's not a great picture either. So our fresh water systems are in crisis globally and locally. And we must understand this. This is not a problem for the global south. I'm not confident. The average actually in Europe is about 60%. I'm not confident that Europe would fare any better actually, because I think the implementation of it is just flawed. It's very, very difficult to go out and measure these things. I know because I've done the Ganges, okay? And I know the effort that took once. You know, you've got to do that every year at least, haven't you? Or twice a year. So it's really, really, really difficult. And some of these shouldn't be a surprise. You know, we know we've got issues around the release of diffuse pollution in agriculture. We know there are, you know, we have to address that. It is something that is coming our way. We have to try and do something about it. Whether it's more efficient use of fertilizers, whether it's recovery, whether it's buffer zones, whether it's changing agricultural practices slightly, but we have to somehow grasp that, whether it's growing plants in on the side of buildings or using hydroponics, but we have to have a better mix of how we do things. But also our water companies are letting us down. You know, in 2020, and I think this is maybe, I think UK total actually, 400,000 instances of untreated sewage discharges, 400,000. Now we're being told that these discharges only happen when there's lots of rain. Well, they don't. They happen maybe when they want to save a few bob on aeration, yeah, because that's the main cost in wastewater treatment. They maybe happen because of operational difficulties. But we have a fundamental problem in the UK in dealing with our wastewater, and that is not acceptable. I was ashamed in my recent visit to Copenhagen at the World Water Congress. Ashamed, yeah, because we were discussing this. And not one representative from the water industry was at that conference because of the death of Her Majesty the Queen, right? And I thought that was pretty shameful. I think it's time to, you know, this is not about finger pointing, it's about solving problems. And we need to get together and solve problems. And there are things that we can do. So this has been widely reported, and there's a little bit of a fight between agriculture and water companies because, you know, they want to apportion blame. So we only cause 20%, or we only, it's really irrelevant because the rivers are all of our concern. They should be all of our issue. And we need to work together to try and resolve some of those things. So when we go back to this way of looking at things, and I've been telling you about all this wonderful processing that occurs underwater, out of sight, you know, and it's been happening since the dawn of time from a planetary perspective anyway. So we measure these physical and chemical things, and we measure these invertebrate things. The thing we're not measuring is this biogeochemical thing. It's this microbial interaction thing. And that's because it's really, really difficult. Yeah, we don't really have the technology at the moment to really get an insight into that. And that's what we're spending a lot of our time on, is developing approaches to get a little bit of an insight into this biogeochemical pump, yeah, this biogeochemical processing. It's like fundamentally a pulse or a heartbeat, because it's a living thing. You know, you don't have fish. You need the nutrients to drive this system. But if you don't have that biogeochemical processing, you do not have all the other things that we enjoy and are very obvious in rivers. And we're using something, this is going to be like the last couple of slides, but we're using something called fluorescence to try and pick up that biological quality of rivers. And what we know about carbon and very big organic material is it exhibits fluorescent qualities. Not all of it does, but a significant portion of it. So the stuff that comes off peat, yeah, or high peatlands and all that kind of stuff is often very brown and very tanniny. And again, we were talking over lunch about leaves, you know, falling from trees. Drivers like that are driving carbon. You know, they're putting, you know, photosynthesis and sunlight are making and building carbon structures and then releasing that carbon back in the environment. And through the process of this biogeochemical action, we're releasing that carbon back into the system. And we've picked up a couple of interesting things there. And we refer to these as regions T and region C. But essentially, and this goes back to my PhD, where I was shining light on water. What we can do is somehow differentiate between carbon that's a little bit older and maybe originates from some of these areas, from carbon that is produced by living biological action. And what we're doing with that is we've developed a sensor with industry. And I firmly believe industry, you know, I was not very keen on industry, if I'm honest, as an academic. You don't really go into academia to work with industry. But I firmly believe now, 30 years later, that industry and business can rescue us from this. I have no faith, sorry if there's any ex-government workers here, but at the moment, I have no faith in government solving this problem. I think government can help and they will be required, but I'm putting my all my eggs in business and technology companies and the third sector, you know, the non-government organizations. What we need government to do is to provide, you know, the framework, provide the playing field. And we've got one of these sensors deployed. And this sensor measures these two different types of carbon. And we're doing it every second, and we're collecting that data hourly, every day. And it's sitting on the river Taplow. I don't know if any of you know that river. Sorry, not Taplow River, Jubilee River. It's a kind of a flood defence for the Thames. So it's down near Reading, Maidenhead, and they divert the Thames, and then there's a big sort of flood defence, which is the Jubilee River. And you're not allowed, there's no development or anything there. It's purely there to handle volumes of water. And we've got this high resolution station sitting there doing all these measurements along with other parameters that we're looking at with our partners. Eva's the star for that. We've published a paper which is developing that biogeochemical processing. And all of these papers that I've shown you are free. So you can, you know, Google them and access them. They're all open access. That's our firm belief. That information should be available to everybody. And this is sort of going back to sort of good old-fashioned science, you know, taking proper living models and developing them on the bench and then trying to roll that model out into the field. A lot of my colleagues spend a lot of time doing genomics and analyzing bioinformatics, but I'm a bit old school. I like to poke things and see if it moves. And I like to see what color it is. I like to see the morphology. I think we've got a lot to learn there. And we've got some really interesting information that bugs, when they're processing stuff, they don't just break stuff down, but they also build carbon as well and stick carbon together. And that's new. So these rivers could be acting as sinks, not necessarily emitters. So we're bringing that into the mix. I'm going to try something. I'm going to see if we can tune in live to Taplow. Are you there? It's like some mutated, warped version of the Eurovision, isn't it? Taplow, can you read us, Taplow? We'll accept the terms. I'll move this across, it's probably a good idea. Right, okay. So here, we're now looking live at a river, okay, and we're looking at this carbon that I told you. The bottom graph is chlorophyll, so that's all about algae and things like phototrace, and the sort of slightly turquoisey one is the peak T. So hopefully all you online viewers, you can see this trace. And I'm just going to try and, I can see Eva just screwing her eyes up thinking, don't, but I'm just going to try and manipulate something here. So, right, yeah, that should be good. All right, okay, good. I don't think I can make it bigger, unfortunately. I can zoom in.
I don't know about the whole screen.
Ah,
Yeah,
with the,
those little bits. Yeah.
that one.
Either that one.
That's zooming out.
Yeah.
Well, that's even better. Right. So here we're looking at a whole trace. And you can see you've got these lots of interesting things happening. And we've picked up here things like algal blooms. You might all be familiar or have heard about algal blooms in rivers. And what we think we're seeing here is that, you know, that breathing. The breathing of the river. Yeah, it's a living thing. It's metabolizing. Right? It has it's a big, giant digestive network. And the things at the top are all the other more traditional parameters that we're measuring too, a little bit more complicated. And ultimately, our ambition is to realize an entirely new water quality parameter, what relates more specifically to ecological health. So the things, you know, the fish and all the invertebrates, we're looking to see what is the status of all this, for want of a better phrase, gut biology. Yeah, we all know, don't we? Our tummies are a good starting point to know if we're feeling well or not.
Can you tell us about the x-axis on the bottom graph at all? It's something dramatic's happening at the very beginning, and it seems to go right down and sort of stabilize.
Yeah, so quite often when we see those things, that probably could be a period of rainfall. So quite often if we get a big period of rainfall, you can see that fish, and we have to backtrack and, you know, sort of look at dates and then see what's happened. It could be a bit of maintenance.
That was a big algal.
That was the algal bloom.
In the beginning of the, well, it was in spring. But if you look at the top graph, can you see the green line? It's matching it. So we've actually got two sensors. The bottom one is one sensor. That's the fluorescence that Darren was talking about. And then the top one is not fluorescence, it's looking at kind of other standard parameters, but one of those is chlorophyll. And you can see the green line, that's chlorophyll having a big kind of
Bloom.
increase. Yeah, so that's telling us that it was probably an algal bloom. And then, you know, what you can see on the bottom graph is the other things that the algae producing. So things like amino acids and proteins that they produce when they metabolize.
So that metabolic activity, and they have a funny, you know, they have a not love-hate relationship, but it's a balance thing. I mean, evolution has driven this. You know, you need your heterotrophic bacteria, so stuff that can't make their own food, or just bugs, and there's lots and lots and lots of them, but also these phytotrophs, and they're competing for nutrients. Now, the problem we're having in a lot of our rivers is we're giving them, it's like having a party full of 5-year-olds and providing unlimited Haribos. You know, it's just get on with it. You know, imagine that. And that's what we're doing. So we're over nutrifying our rivers. Yeah, and the biology is responding to that. What we need is technology that can help us control and manage and provide high-level intelligence. So we know where problems are. We can go and sort it out. We know maybe there's an event coming, because releasing sewage in the river is not going to go away anytime soon. Yeah, that's not something that is in the gift of the water operators because of the way our system works, right? But we can manage it better, and we can have better intelligence, and we can make places more enjoyable for humans, as well as making those places more supportive of the very things, you know, that make that blue planet that I showed you right at the beginning so special. Because if we don't act now, and that's an intergenerational thing, you know, we're going to be in big, big trouble. And I'm saying that, and I'm an optimist, and I've been working in this area for 30 odd years, you know, and it's really difficult. But I have faith in technology, I have faith in science, and I have faith in people, actually. But we have to wake up, don't we? Whenever you do anything like this, there's always loads and loads of people. It's never one person. It is a collective endeavor. So that is just a quick shout out to some of the the people I've been slagging off, like the government, who gave me lots of money to do it, which is fine. But also, of course, lots of people abroad, a lot of my colleagues in the other institutions. And, you know, don't underestimate, you know, when you're doing research, professors, they come out and tell you about the research, but it's not the professors that are at the bench. It's not the professors that are doing, you know, 8-10 hour shifts for pretty much £17,000 a year, £16,000 a year. It's, you know, they're down to the researchers. Yeah. So it's their dedication really that I would like to dedicate this presentation to. So thanks very much. Thank you.
Well, Steve, to cut down.
Yeah, it's brilliant. Yeah.
Well, I told you he's passionate. Right, I think what Darren would like is actually, rather than questions, a discussion. So, who's going to kick it off?
Well, I have a question on Zoomland, which was more of a comment than a question, really. John Hill says, surely Brexit means that we do not have to achieve the high EU standards, and the ability of water companies to discharge sewage at will must be constrained.
Yeah, that's really good question, actually. So actually, since we've Brexited, in November last year, we redrafted our whole environment kind of legislation, which passed in November as the Environment Act 2021. And in terms of water quality, freshwater legislation, we have actually kind of essentially transplanted the Water Framework Directive as it has been since 2000
So we've
in the
kept the
European
EU
Union
standards
into
effective.
the and then but one of the main differences has actually been sewage pollution. And that's been something that only got released actually last month in September. So it was a long awaited piece of legislation that the government were drafting up. And, you know, the water companies, the Environment Agency, everybody was waiting on what's this going to mean for us. And the outcome of it was that water companies are now required to monitor upstream and downstream of, I think, pretty much every single combined sewer overflow of untreated sewage in the UK, which I think is about 18,000.
So they
So it's a
actually
lot.
have to monitor now what is
Yes,
being done.
but then it
Well,
goes back
you
to the
say
issue,
monitor, they
what
have
are we
to-
monitoring
I
kind of
mean,
thing.
they should. I mean, water companies know if they're opening a sluice gate or not, because someone has to do it, or someone has to press a button. So it's not so unfamiliar really with what has been coming out of recent weeks. Is the detail. So what do they mean by monitor? So if all they're going to monitor is, are you opening it, and is it discharging? Well, it's a bit like, you know, that's not where we need to be, is it? Because it's once it's out there, and once it's in there, it's in there. So I think there's a big contentious issue about what do you mean by monitoring? Do you just mean monitoring flow? Do you just mean monitoring pH? What do you mean by monitoring? So, because we've spent the last 50 years monitoring stuff, measuring stuff, not very regularly, and it's the wrong approach. So in some ways, it's kind of panic policy because it's sort of be seen to be doing something. The water companies are in a difficult position. I don't have a lot of sympathy for them, but our sewage system is a combined system. So when you put your tap on, and you have a bath or you enter the sink, it goes down the sewage, works. It's the same place that your human waste goes. Other countries have separate systems. Phosphorus, which is a key driver of nutrification, we put about 2 milligrams per litre, which is a lot of phosphorus or phosphate in our drinking water, because it stops it chelates or scavengers lead. So, but where does all of that drinking water go? Where does it go? It ends up in the treatment works. So then the treatment works have to remove that phosphorus, and if they don't do a good enough job, it ends up in the rivers. So there's just too much. It's too much not smart stuff. And we've all been fooled. I mean, you know, or many customers have been fooled that they think the water companies are doing the best, and they need to do more. And it really comes down to investment. It's simple as that. And we have a unique model in not unique, but all of the water companies in England and Wales are all privately owned. In Scotland, they're publicly owned. In Most of the European countries, they're publicly owned, or there is a hybrid model of public and private ownership. And the reality is there needs to be more targeted and directed investment in infrastructure. And that's not happening, because they're important for pensions and they're important for dividends. So we have to reframe and reorganize. This is not about being a lunatic left person. This is about, let's sit down and let's be sensible. What can we do immediately? What's the low-hanging fruit? Yeah, but what should we be aiming to do in the long term? And the fact that we still have lots of lead pipes, I would argue, is not good enough. I think companies should be, at the very least, tackling that. Yeah, we should not have leaking pipes. Yeah, and we should have, where possible, in new builds, for example, why can't we have containers or holding tanks or holding places for all new builds, new houses? So when you do get a lot of rain, there is a little buffer, because a lot of that pressure is coming from runoff. All the runoff of your roofs and everything goes down that sewer, and that is putting pressure on the sewer. That's useful stuff. It's useful for your garden.
Mandatory in Bermuda.
Yeah.
Yes.
And
every house has to be self-sustaining with their rainwater.
We had a wonderful lecture on it.
Yes, we
didn't
did. Yes.
And that's an excellent point. When you look at other places, they have a different relationship with water, and they think we're crazy. We're washing our cars with drinking water. I mean, the biggest killer on earth is contaminated drinking water. Yeah. Biggest killer in kids under 5. 1.5 billion people do not have access to safe water. So our relationship is wrong, and we need to, and there's so many things we can do. This is not about going back to some medieval way of life. It's a combination of lots of things, being better at farming, being better in your own home, being better in government. We just need to be better because we deserve it, don't we?
But even if the water companies do publish or do monitor, are they going to publish the data?
Yeah, they have to make it.
But where are they going to publish it? Because you were saying earlier, the difficulty you've had actually discerning material in the public sphere.
Yeah, so they are required to publish it, but again, it's inaccessible. But actually, that's where quite a lot of kind of third sector initiatives come in. So if anyone's heard of Surfers Against Sewage, they have a big collaborative campaign alongside the Rivers Trust. They've kind of extracted all of that information. So every time there is an untreated sewage discharge into either the coast or most of the rivers in the UK, that's actually monitored, and they put it all in an app that you can access on your phone. And it's called the Safer Seas and Rivers app, and you can look at your local river or local coast and see a notification alert thing, basically, when it's discharging. And if you look at it on a rainy day, it's just full of big red crosses.
I was horrified to go on holiday a couple of years ago to Combe Martin. You should find the beach there. There was a sign up saying that they would say when the beach was safe or not safe because of raw sewage.
Yeah, and not many rivers are safe to swim in, I'm afraid. It's very variable. And a big shout out to a lot of the NGOs. I mean, I think there was a time when Surfers Against Sewage was seen as this kind of quite annoying little, sort of whatever, fringy type thing. The thing what I'm finding is a lot of these, kind of groups that are being very active, is they're getting their act together, and they're actually going down the science route. They are going down. They're pursuing their endeavours through science and through technology adoption, apps and things like that. The water companies aren't. But all these sort of action groups are, whether it's the rivers, trusts, whether it's Surfers Against Sewage. There are a lot of active groups in relation to establishing bathing waters on rivers, because, I think it's okay to say, actually, I want to go for a swim in a river, and there should be facilities. In Copenhagen, their entire dock, if you like, this harbour, the entire harbour is open for people to swim, and they publish information. If it's not, and it's not always safe, but they publish that information. But there is a new ambition in the city. We want to connect people with the environment. Why not? It's water. Go and swim. and there are places to change, and there are places to, little pontoons and let all that kind of stuff. And what do we do with a lot of our rivers? First of all, you get told off. This is my river, not your river. There's quite a lot of that going on. There's a lot of rivers where you have lots of high walls and fences, because they clearly don't want you to go in there, and you peer over and you see a shopping trolley and a couple of road cones and stuff like that. They deserve more respect than that, our rivers, because they're doing a really interesting, and it's funny, that relationship, and who's driving that relationship. It breaks my heart when I go down Bristol city centre and places, and all the places where the houses are really expensive, you've got beautiful access. You go out into the slightly more suburban areas. No, you go, stop it. No, not in there. Gates, walls, keep out. And it's not telling the right stuff.
I mean, over the last 20, 30 years, there's been a lot of ambivalence on this, hasn't there, from the general public. Now, with the way going, peer pressure is starting in our own river colony here. Just that little bit, Thames water being down because of peer pressure.
Yeah.
We're doing is invertebrate monitoring and this sort of thing. Isn't it up to us as much as anything now to actually do our own testing, do our own pressure on these people? You say they don't publish, which they don't, and as you say, the companies, then we have to actually independently put the pressure on, which seems to be happening. Not
it is. No, it is.
I think
it is.
that's the whole reason why we even had this policy change in the first place. Like you were saying, it's not enough, but the whole reason it's happened is because there's been public discourse around it. There's been pressure because it's been getting the airtime that it deserves. Finally, actually, credit to the media about that as well. And the public who over lockdown realized that actually, particularly in urban areas as well, like in Bristol, we don't actually have that great access to the outdoors, especially not blue spaces. So people are finally thinking we should be looking after them, and they're putting pressure on the government, and the government isn't responding as much as it should be, but it is responding. So
it will eventually. Well, the government, that's the way the government will respond. People say you've got to do something, and enough people do it, they will change.
But they're missing out on the blue economy. There is. It's not a sort of this idea that you rejuvenate these things and that they have nothing to give in return except clean environment is really misjudged. And I think they just need to understand the connectedness, and about the benefits economically that can bring.
We often hear about the fact that there is pollution from farms by way of weed killers and fertilizers and such like. Is this just a dig at farmers, or does it represent a real problem?
38% of significant water quality pressures in Europe are from agriculture. So it's very significant,
Is there any comeback? What is the sort of punishment? What can happen if farmers are found to be doing it?
You can't stop them.
Depends who finds them. If it's the see, they'll get a slap on the wrist.
There are nitrate vulnerable zones.
Yes.
Things like that that limit your what you're allowed to put on the land. You have to do a poo count every year as to how many animals on your land have pooed and how much poo they produce.
I think I'm sympathetic to farmers, actually.
It's true, I have to do one every year.
So do you work in agriculture? No. But
we have a piece of land.
Yes, okay. Right.
So we have to do that.
So I'm sympathetic to farmers. I mean, they've got a tough business. They've got to grow food, and a lot of farms, in my experience, are not. They're not raking in loads of money. So we have to provide the stimulus for them to do the right thing. We have we drive down the cost of everything, and we have to reflect the true cost. This is not about having the true cost in supermarkets, because you have decisions to make, but we have to reflect the true cost of doing something, and then we can intervene in all sorts of different ways. And I think we don't do that enough. We want cheap food in our supermarkets, and then I understand that, but we've got to do things differently,
One area you haven't touched on is the particulate matter. We're at the moment working on a project where we want to get people out of their cars into light railway, and what we're trying, obviously we have to produce a case to convince people that this is the way forward, and at the moment they're only touching on the particulate matter between the tyres and the tarmac, which obviously, as far as we're concerned, we see that running off into the rivers. is there any work on actually that aspect of pollution? And are there any studies that we can use to support our case?
There is some, to my knowledge, studies related to particulate matter emanating from tyres. Off memory, that's certainly the case in air. Whether or not it specifically links and relates to runoff and road runoff, but there might be something there. I mean, please email me. Yeah, and just say that. And then at the very least, we can have a quick search for you. And we can send you relevant links or relevant papers.
Very helpful, yes. I assume that it's in the air for a while, and sooner or later it gets washed down to the ground, and then it goes into the rivers. So anything that, unless it ends up in your lungs, then it's finally going to be in the rivers.
It's going to contribute. I mean, deposition and particulate deposition from the atmosphere is exactly the reason why we have a lot of these pesticides. We detect them in the Arctic and the poles is for that. So that is a contribution. Absolutely, yeah.
Would your fluorescence system in tap not pick these?
Well, the thing is about when you look at particulates in water, we use a parameter called turbidity, and it's really just it's on light scattering, but it doesn't differentiate with what it is. It could be a grain of soil, it could be a sand particle, it could be a bit of rubber, it could be a microplastic. And that's very different. They're very, very, I mean, I thought I've worked on a lot of rivers, but my work and time in the Ganges, I mean, they have huge, big flows and big changes in parameters. It's a really big system. And we were having a lot of trouble dealing with just the massive variations, things like particulate matter in flow, all that kind of stuff, really huge. So it is a big challenge. And the other problem with this type of research is I get a widget, okay? I think, great, I've got a widget. What market is that widget going to occupy? Where is that going to go? Who's going to buy it? And when I'm working with technology partners, fundamentally and ultimately, they need a market space. They can't just make it and then, people have, and that's a really big problem we've got. We put a lot of money, billions of pounds into research, and we hardly do anything about creating market spaces. And we should, it's all right telling the world that we're brilliant at everything, isn't it? And that, I mean, the number of times I hear world beating and stuff is like, whatever, but what are we doing with it? And how are we using it? And how are we implementing it? And that's a big challenge. That's that science policy interface. And that, to me, is a really urgent thing that we need to do, is getting all this good research that happens throughout the world in the UK and getting it into a space that is usable. And I can't do that. That's not my skill set, and I don't have that capacity. Companies do, but they've got to have a market in which to go into. There has to be a financial mechanism by which they can deploy this technology and get some return. Otherwise, why are they going to do it?
There must be industrial applications that can be applied using this, surely.
Yeah, I mean, one, I mean, I used to get wheeled out about 20 years ago. I used to get wheeled out at the end of there used to be this thing called Sensors for Water Interest Group, and it was sponsored by the water companies, and they used to wheel me out at the end of every weary session, and I was the bloke that would talk about the future, so I said, we're doing this, and many years ago, and it'd be, you're doing that, yeah, and it would be about measuring the quality of sewage, so you can adjust how much energy you use to try and treat the sewage, because you know how much you start with using these sensors. Also, there's a sentinel means for monitoring sewage discharge and things like that. But when it comes down to it, there's something in the way we run our water and the business of water which doesn't provide enough space for innovation.
Yeah.
So in the end, I just stopped going, because there's only so many times you can give the lecture about this is what's happening in the future.
Well, the other point is
because the future became the present.
Trick the universities possibly have missed, and that is the citizen scientists. Here they are. Absolutely.
Well, that's another really good point. I mean, a lot of the like the Rivers Trust, for example, and a lot of organisations like Service Against Sewage, they do extensive programs for citizen science, and it's a bit like the RSPB. When you do the bird watch every year. And there's lots of things that I think we need a bit more coordination. I think universities are not the right places for that. Personally, I think those other organisations are much better placed because they're generally a lot more connected with the communities that they're serving, and it is a voluntary type relationship. And I think that is a good vehicle of doing it. I think we need more of it, and I think the water company should stump up the cash to enable that. Quite frankly.
Ultimately, though, with the water companies, what you're saying earlier, I agree with that. See every word, but I'm thinking this ultimately is going to mean everybody's going to pay more for their water. Now, are people prepared to do that? And
water is not comparatively that expensive, though. When you
but if
think
it's
about
twice
it.
as expensive as it is,
Well, people don't moan about their water bills. I mean, you're right. Nobody wants to pay for anything.
no.
But I don't know about you, but I'm not moaning about my water bill. I know what bill I am moaning about. You know, that's like, you know, really bad. But for about £2, maybe £2.50, you know, you can get a ton of clean drinking water delivered to your upstairs. That's 1,000 litres. That's not bad. You know, that is not bad.
It sounds like a bargain.
Well, you know, well, I think it is. You know, I mean, I think we have to understand that there is a cost. And we need to reflect and understand the cost through the whole cycle. Yeah. Now, I'm not saying we have to pay the full cost. We've got choices to make, haven't we, as a society? You know, we have choices to make and decide, yeah, through all the various means. But we need to understand the true cost of doing those things. If you buy water from in a plastic bottle, right, which is like a massive waste of everything, as well as causing the problem, and actually is about it's about 500 times more expensive or something than the water you get from your home. And there's no proof that the water quality in those bottles is any better. No. And I've done some stuff. I appeared with Hugh Fernley-Whittingstall on the War on Plastics on the first episode, and we were doing lots of tests on bottled water, and he was going around some town selling, you know, just changing the label, and everybody thought it was wonderful. You know, I think it was called Tapano, I think. He was on Johnson Tapano, he was in disguise, and they were always absolutely, but there's no health benefits. And in fact, the water in your tap is more regulated than the water in those plastic bottles because there's much more testing that goes on. So I'm sticking up for the water industry, right? So I'm not all bad.
So you want the people that are marketing the water bottles to be marketing these widgets.
Yeah.
So you want.
Instead of mixing lots of clean, pure rainwater with sewage, it seems the most extraordinary thing. And the problem that we have of putting sewage into the rivers is because we're mixing all this pure, clean rainwater with the sewage, so it overloads the sewage works, which I've been round and seen how it works.
Yeah. And there's too much water, and the changing environment is making, you know, is big challenge for the water industry. I mean, you guys know, right? I mean, I've lived a reasonable life. There's lots of very experienced people in this. I mean, if you speak to people on the street, you know, they will tell you weather has changed. Has weather changed?
Yeah.
As the pattern of it changed.
Yeah.
I mean, you don't need to give me £1 million to go off and do some, you know, research and all that kind of stuff to work that out. People who are going about their daily lives have got very good indigenous knowledge about the environment, and we need to capture that and use that a lot more, and we don't. And you're right, there's too much water. So we need to now start a really big ambitious plan about managing that water, not building on floodplains is probably a good idea. Yeah, having sort of water catchments, you know, new builds is probably a good idea. Integrating and requiring rainwater harvesting, you know, is probably a good idea. This is not, you know, we've got what we've got, but we don't have to keep doing the stuff that we know doesn't work, I think, and we do.
The sensible suggestions. It's not like people saying every new build's got to have rainwater valves catching.
Yeah.
Well, they're so close together. Half the time, I found they take them out. So when they're full, you've still got the runoff, you know, sort of thing. Yeah. But you say about our water systems. You say about a lot of tap water going into sewage. Well, I know around here, a lot of the water systems, it's the runoff from the roads, which then, because they're all dual systems, and our climate has shifted to high sort of sudden rainfalls, and it just can't cope. So the investment that's required
is large. But I don't think, I don't think we have to apply that uniformly across the country. I mean, I think urbanized areas are much more problematic than less urbanized areas. And I think, it's about, and we have to understand the water catchments that you're in, because that behaves, not all water catchments are the same. So there's a whole set of information that you need to bring together and come up with tailored solutions for each of those things. And it is entirely possible. Other countries do this. Anybody who's been to Cape Town, I mean, they've had droughts for months and months and months and months. And innovation, is, with necessity comes innovation. And they're much far advanced in how they're thinking about their water than we are, because we're lazy a little bit of that, because we think we have a lot of water and we think it's not a problem. But water is projected to be a major critical need in the next 30 to 40 years. So I'm cheering you all up, aren't I?
Sorry, just to widening it there, you mentioned about the Ganges. I spent a lot of my life in developing countries, the water, agriculture, education. You're looking at the end result in the water, but what's being done about educating people in countries about the effects of sewage and what they're doing? It comes out of governments and investment, but the religious side of it and everything is the biggest problem.
Is a big problem. Yeah. I mean, you're right, and those are very difficult things. Again, I think there's a lot of activity with non-government organisations. So we work with a lot of Indian NGOs, and they're working with communities. And it's just, the governments, the respective governments, number one, have to get their house in order. So India, is an interesting. It chooses where to spend and what to spend on. It has quite an active space program. So there are a lot. It's a very dynamic thing. But in some ways as well, they're doing things a little bit differently to us, and arguably a little bit better, because when you have different resources and you have different constraints, you approach things in different ways. So I think there's a lot of sharing that can be done. But fundamentally, of course, you're right, and those things are enormous obstacles to kind of address, really.
Right, last questions. I think we need to really wrap up now. It's after 9. Yes.
No pressure.
No pressure.
I can see it's all about infrastructure, old infrastructure, and it needs to be replaced and changed. So which countries have a similar rainfall or climate to us that have got it much better than us? What's it look like? What's the difference between ours and theirs?
I mean, it's really difficult. I mean, the UK is very dense. That's a big difference for us. I think when you look at Europe, the Dutch are very innovative with water. Now, a lot of that's because they're very low, so they're sort of. But again, it's that necessity, isn't it? So they are generally very, I would say, one of the most advanced nations in terms of water. The big thing we've got to do is to drive innovation. It's not that we don't have good ideas. It's just the water company isn't accessing innovation. They just launched a £200 million innovation fund. And that was launched by Ofwat. And that sounds great. And we're talking about this at the conference. And everybody was like, that's amazing. You got 200 million. When you really know what's going on, Ofwat have said to the water industry, you're not innovating. So we're going to take away £200 million and put it in this pot. If you want your money back, you have to innovate and get the money back that way. So they've been running that for a couple of years. And guess what? The ideas that they're putting forward aren't very innovative. So they're now changing the rules and saying, okay, so what you can do for this next round is go to people like Darren over there, or some person, some NGO over there, and now they can put in the idea for you. So actually, I think a lot of the trouble is from government, and it's not ambitious enough. A lot of it is the sector. So you've got government issues. You've got a sector-wide miasma state where they're just not being innovative, probably because they're not encouraged to innovate or the incentives aren't there to innovate. And thirdly, you've got extremely poor regulator who's got, they're just too crazy with each other, and the Environment Agency have been completely rinsed. So they've got nobody there. All the Environment Agency spend 80% of their time floods because that's what they're being told. And I understand that, getting affected by flooding is horrible, but it shouldn't be an either or. And they've lost good people in the Environment Agency because they don't do monitoring. So they monitor rivers once every 5 years.
Well, that very depressing.
On that cheery note.
I think we're wrapped up. Thank you so much, Darren, for a really interesting, stimulating lecture on something which we all should be involved in, I think. Thank you.
It's been a pleasure. Thank you very much.